Hi, welcome back. It's Andrew Wheeler here. Today, this short video, I just want to go into a bit of background on the file structures that we generally use when it comes to CAD design, scans, and intraoral scans. Now, one of the real strengths of Blender is that we have a lot of tools and a lot of features that we can use to fix scans and get around problems relatively easily. So we'll have a look at the files and how they're made up and what generally are the problems with them. And then we'll go through a little bit on how we fix those and work around them and the common problems that we see. So what I've done here is I brought in an STL file. This file is the one that is in the BD Blender4Dental folder that we can work with. It's a nice file, um, and there aren't too many problems with it. But what I'm going to do now is I'm just going to go and give you some options. We've done the arch cut, and there are several other features that we can use to tidy up scans. Now, just a little bit of background is um, the file that we use. So STL file, if we highlight this and as we've done before, gone into edit mode, we can see exactly what the STL file is made up of. And in this case, we have got, let me just pop back into the object mode. This file is made up of 101,000 vertices. Now, vertice is the little black dots that you can see there, and each vertice is joined together by an edge. Now, one of the great things about Blender is that we can manipulate these details for various reasons. Here we have a little box over here with three options. Each one of these relates to a vertice, an edge, or a face. Here you can see we've got the vertices highlighted, so we can sit there and we can click on a vertice and we can delete it, we can move it, we can scale it, we can use it however we want. We can move over to an edge, and there you'll see the vertices have disappeared, but then we can highlight the edge of the STL file, or we can actually highlight a face. Now, all of the 3D software on the market use the same sort of way of manipulating scans. The difference is with Blender is that you can actually sit there and play around with it, whereas a lot of the other systems, XCAD and 3Shape, they're all sort of, this goes on behind the scenes. Now, why would you want to do it, you ask? Isn't it easier to let the computer? Well, it is, but there are times that it's very useful to be able to manipulate the file. We tend to get some ropey scans in occasionally, scans with holes in, and it's important that we know when we work down the work process, when things go wrong, is to be able to identify why they've gone wrong, and it speeds everything up. Now, I've said many times before, um, it's very important that we understand what's going on behind the scenes when it comes to these softwares, whichever software you use. If we understand what's happening, we can isolate where the problems are when they go wrong. And understanding how file structures work is no different than understanding what happens when you burn wax out in a furnace or you fuse porcelain to metal, any of those things that we're used to and we understand. It's exactly the same with CAD design, is that we need to know what's going on behind the scenes to help us understand what we're looking at and what we're seeing. Not only that, but also to help our clients and patients in getting the better result at the end of the day. So, having said that, one of the features that Blender uses is cutting tools and editing tools within the software, so we can start to manipulate the scans and fix things when they go wrong. One of the most common problems that I see is holes in scans. And on first inspection, the scan looks complete and it looks fine. but you will only notice you get a hole a little bit down the line when you try and base the thing. So let me just give you a quick demo of what happens. So in this case, what we'll do is we'll go into edit mode. We will select a face and we will zoom right in and we will find a face and we'll delete it. Now, effectively, there is now a hole in the scan. This hole you can see, we know it's there. Many times you won't see this, you won't see the hole. All you're going to see is a problem down the line. So when we want to put a base on it, for example, once we've done the arch cuts, we've done our alignment stage, we've gone all the way down, everything's looking great until you turn it over and you see there is a problem with the file. And that is going to cause a problem when you print it. If you wanted to take this out, this die out, that's not going to happen with this issue we've got here. If you find that's happening, all we do is we Control Z, we go back one space, we find the fill hole option, we click on that, even if we don't even know how, can't see the hole in it. Back to the base, click on the base again, and we should have fixed that issue. So we flip it over and there we have it. It's all complete and we know there's no problem with it. So it's knowing down the line where these things go wrong and how you fix them. Another very quick little useful tool, go into edit mode, is fixing areas that are missing. I don't like to do this too often because I think it's incumbent on the clinician to do a good scan, but it's easily done if there's areas of the scan that are missing and you need to rebuild them, if you like. We highlight a vertice, make sure this is on the vertice option. We find another vertice that we want to fill, so this area we want to fill up. Press Shift and left click to highlight, so we've got two vertices to highlight. Press F to fuse that, and then click on the fill hole button, and then that will fill that hole up. Now, effectively, you could work your way around the scan, and you could make your edge really nice and neat. It's not really a problem on this because we've got plenty of data and plenty of scan that we can work with. But if you did need to fix a scan, it's a very simple, quick way of doing it. Along with the arch cutting tool, we have other tools that we can use. We have cutting tools that come in very, very useful. We will go through these in more detail in other videos that I'm going to do, but I'll give you an example in how it can save a lot of time. Sometimes the arch cut, it doesn't work that well depending on the scan we've got and depending on what we actually want to achieve. There are times when something like a curve cut makes our lives a lot easier. So we put make sure the model is highlighted, we put our cursor down and we click on curve cutting. This puts a circle in the area. We can then grab that circle by pressing G or scale it with S on the keyboard, so we can move it to an optimal point. We then have the option of shaping by highlighting a vertice and pressing G on the keyboard. We can move around. We've sunk below the line there, so I'm just going to move that back out again. And we're going to click keep outside because obviously this is the outside bit we want to keep. There it's given us a nice cut. That's if you're looking at it from the top, then obviously you see the cut. If you're looking at it from the side, you can also move the cutting tool. And this cutting tool will cut anything that sits below that line. So we're happy with that. So then we'll accept that. And as you can see, it's given us a nice arch cut. This is great, and this this really comes into its own when you're doing sort of things like implant trays and stents, and you want to punch holes in things and create access holes. Works very, very well. So that's another one. One of the other very, very handy tools is the fast edit. So if we click on this button here, the model goes into wireframe. We press C to create a little circle, and then press the left mouse button down and hold it, and you can paint an area that you want to delete. Get another very, very quick tool. So there we have it. We come out of that and we delete it. Bingo, done. It doesn't give you a fantastically finished edge, but if for speed, if you wanted to just tidy up an area, especially around sort of the heels and around the back of the arch scan, you get rid of it very, very quickly by using that tool. So it's just a few points of what we can do with a scan. If you understand how scans work and what they're made of, it does make a big difference in your journey through Blender and understanding how to get the right result that you're looking for. I've said before, there's a lot of much more in-depth and detailed tutorials on the Blender website, and I really strongly suggest you look at that and work your way through those. This just gives you an overview, gives you a very speedy way of looking at getting an end result quickly and seeing that if there's any problems, how to get around them. But the more you understand, the more you can manipulate scans and play around with scans in the working environment, the more satisfying and easier your journey will be with Blender. We'll just go over the OBJ file just to give you an idea and a comparison of between the STL and the OBJ. So we'll hide the STL and we will open up the OBJ. Now, you might get these, you might never see them, but a little background on them. OBJ files are a lot bigger than STL files. OBJ files within them contain texture and color and other various bits of information, which make them a lot more accurate files than the standard STL. Now, STL files mainly used by hobbyists and the dental industry, whereas most 3D CAD design areas use OBJ because it's a much better file system. And as time moves on, I'm sure the dental industry will catch up and we'll end up using the OBJ files as well. The downside with OBJ is they're very big. So they really require a lot of processing power to render and manipulate. And you can see that from this scan here. This scan has got 800, nearly 900,000 vertices, where you compare the STL, which is pretty much the same looking scan, type of scan, although it's an upper, it's got 100,000. So there you can see big difference in the two scans. Blender have got an option here of the reduce model file, and this is where you would use this option and reduce that file size down to a manageable level. You don't want to go too far because you're then going to start to lose detail. The way it works is that if you can think of a sphere and you want to cover that sphere with little triangles, to get it looking like a sphere, you've got to have a lot of little triangles. The smaller the triangles, the more rounded that shape's going to look. But if you zoom in, you will see that it's not round, it's not smooth, it's full of triangles. Whereas the OBJ file will follow the surface of that original object a lot closer. So hence you get why you get a lot more detail in an OBJ file. A lot of the scans that you get from dentists use OBJ because they need the color formats. So when you get a color scan, that when you see it in the portal or the software that the intraoral scanner is used, you'll see tooth color and nice pink texturing for the soft tissue. Unfortunately, you won't be able to bring that into Blender. It doesn't read those color files as maybe like a 3Shape or Emacs. 3Shape or Exocad would. Something to bear in mind. So yeah. Most of the time we'll be using with STL. but it does. This is why they put the import OBJ option in here to allow you to bring files in. So if you get a file, you can reduce it. If we look at this file we've got in front of us here, and we go into edit mode, you can see how much more detailed it is in comparison to the STL. There are an awful lot more vertices, a lot more detail on this scan. Ultimately, it will work the same. You'll work through the same work process as you will with STL. The only difference is really within the importing the file into the work environment. So if you've downloaded a file from someone that sent an intraoral scan to you, you will automatically download it. You'll open Blender up, you'll click on import STL, and you won't find it because the software is looking for an STL file and you've downloaded an OBJ. So it's worth just having a quick look and seeing what they're sending it to you. All of the systems have the ability to send in OBJ and STL. So it's just a case of communication with the client to say, I'd prefer it in this format. It's a lot more manageable. And then you can then view the pictures from the scanner to get the color and to get the details of the texture. Well, that concludes the video. Thanks very much for watching. I hope it gives you a bit more of an understanding of how file structures work and what we can and can do with Blender4Dental. Next week I'll be going over the bracket removal module and the bleaching tray module, which both can be downloaded from Blender4Dental website and added on to the model module. Thanks very much for watching. Please hit the subscribe button and share, and I'll see you next time. Thanks.